Hello, everyone. I am Kyung-ryol Song from Sungkyunkwan University, Republic of Korea. Today, we will be presenting our research on IGNORE, Information Gap-Based False Negative Loss Rejection for Single Positive Multi-Label Learning. In this work, we propose a novel approach to enhance the model performance in single positive multi-label learning. Let's get started with the presentation. Single Positive Multi-Label Learning, or SPML, is a method for a scarcely annotated setting. As illustrated in figure, each image is assigned only one positive label while the other labels remain unannotated. The goal of SPML is to improve model performance in such situations where label information is extremely limited. Most approaches assume unannotated labels as negatives. This assumption is referred to as assumed negative, or AN. This assumption is reasonable because most multi-label datasets are dominated by negative labels. However, by assuming all unannotated labels as negatives, it inevitably provides incorrect supervision for actually positive labels among the unannotated ones. In other words, these labels are false negative labels. These false negative labels can consistently cause confusion during model training and impair the model's generalization ability. So most SPML approaches are focusing on identifying the false negative labels in AN assumption. However, these existing methods have significant limitations. They usually identify the false negative labels by utilizing model output's confidence or losses. In more detail, they identify the labels with abnormally high values of the model's outputs or losses as false negative labels. However, the confidences or losses for the false negative labels are not reliable because models could learn them with noisy labels. To address this issue, it is necessary to consider robust criterion that are insensitive to noisy labels. Since the single positive labels are the most reliable information in SPML, the model's output for the single positive label is reliable. Starting from this fact, we explore a new criterion for identifying the false negative labels. Using class activation maps, we can capture the discriminative areas of single positive label. We can then generate a masked image that includes only the discriminative areas of the single positive label. The masked image contains only the information corresponding to the single positive label. On the other hand, the original image contains information corresponding to ground truth labels. It is reasonable that when there is no information of an object in the image, the model's output for that object is low. Therefore, for the false negative labels, the model's output for the original image is expected to be higher than the model's output for the masked image. In this way, by utilizing the model's output gap resulting from the information gap between the images, the false negative labels would be effectively identified. Here's an overview of our proposed methods. IGNORE. Our method works based on two thresholds. The first is logit gap threshold, which identifies the false negative labels based on the information gap between the images. The second is logit average threshold, which prevents incorrect rejection based on the logit distribution for each class. Our approach excludes labels that meet both of these criteria from the training process. It prevents the model from learning with inaccurate label information. Now let's take a closer look at the two thresholds. In the masked image, the object of the single positive label retains some of its information, but any information of the other objects is completely eliminated in the masked image. As shown in the figure, the information gap between the masked image and the original image is larger for the false negative labels like person than for the single positive labels like horse. In other words, the value of logit gap for the other objects in the image will be larger than the value of logit gap for the single positive label. Based on this observation, we set the threshold using the average gap value of the single positive labels. This section introduces the logit average threshold. As shown in the figure, even if a large logit gap occurs for labels that are not actually present in the original image, we do not need to identify these labels as false negatives. Labels with low logit values in the original image are likely to be true negatives that did not originally exist in the original image. To prevent these rejection of true negative labels in our rejection method, we propose the logit average threshold. It is evident that the logits of true negative labels are relatively low. On the other hand, since the false negative labels are present in the image, their logits are relatively high. Therefore, we only consider the rejection of the labels with a logit higher than the average of the logits for each class. We set the logit average threshold as the average logit of assumed negative labels for each class. In summary, ignore consists of the logit gap threshold and the logit average threshold. Specifically, ignore identifies and rejects a label as a false negative only if the logit gap is higher than the logit gap threshold and the logit of that label in the original image is higher than the logit average threshold. The loss for rejected labels is completely excluded from model training, thereby suppressing the learning of incorrect label information. It significantly improves model performance in SPML. In this section, we present experimental results on various multi-label datasets, Pascal-Vach, MS-COCO, NUSWIDE, and CUB. The metric used in the experiments is mean average precision. The results show that our method outperformed existing approaches on all datasets except CUB. This performance demonstrates the effectiveness of ignore in single-positive multi-label learning. Also, we analyzed the two thresholds of ignore and the logit gap. As illustrated in Figure A, it is observed that the logit gap for SP is lower than that of the FN during model training. In other words, the logit gap is a suitable criterion for identifying false negatives, and the logit gap threshold works effectively. In addition, as shown in Figure B, when logit average threshold is applied, FNTN noticeably decreases. This indicates that our logit average threshold effectively mitigates the rejection of true negative labels. Ignore is a single positive multi-label learning approach designed to identify and reject the false negative labels. Ignore is based on the model's output gap, resulting from the information gap between the images. Through various experimental analyses, we demonstrate that the logit gap is a suitable criterion for identifying false negative labels and validate the effectiveness of the logit gap threshold and logit average threshold we define. By rejecting identified the false negative labels, ignore prevents the model from being biased to false negative labels and built more reliable models. As a result, ignore shows significant performance improvements in SPML and achieves state-of-the-art results on most datasets.